What I'm going to do in this video is I'm going to take you through the double angle formula questions I set last time. I'm going to show you how to work the solutions out and where they all come from. So, quick refresher for you of the questions. So these were them. So I told you if tan x is equal to 2/5, use double angle expansions to calculate these four quantities. So cos 2x, sin 2x, tan 2x, and then the final one, sin squared x plus sin 2x minus cos 2x. Now, I did mention as well exact values triangles would have to come into play, and that's because of this here. So tan x is equal to 2/5, which means that tan of x has come from a triangle where two of the sides are 2/5. So to get cos x and sin x, we have to complete this triangle and make sure that we're able to calculate the missing side. Now, we know from basic trig that it's a little right angled triangle, and if I was to label this angle as x, I would know that using the tan part of SOHCAHTOA, I've got two sides here. Remember, SOHCAHTOA, tan is opposite over adjacent, which means that the opposite side to x is the 2, and the adjacent side is a 5. So I'm able to take this angle here and say, right, for this triangle, that must be 2, and that must be 5. I can then calculate this missing side here using Pythagoras. So we know that this missing side here is going to be given by the square root of 5 squared plus 2 squared. Square root of these two sides squared and added together. Well, 5 squared is 25, 2 squared is 4, so it then becomes the square root of 29. Now, there's no way of simplifying that or actually calculating it and getting a specific value that's not a recurring decimal or a decimal number. So we leave it as square root of 29, so we've got an exact value to work with throughout our calculations. Now, cos 2x has three different expansions we could use. So we know cos 2x to be written as cos squared x minus sin squared x. We know it's also equal to 2 cos squared x minus 1, or 1 minus 2 sin squared x. We should be able to use any of these three and still get the same answer. So let's label them 1, 2, and 3, and just make sure that that works. Now, to get sin and cos, I need to use the triangle here. So I need to use the triangle to get cos x, and I need to use it to get sin x. Now, SOHCAHTOA tells me that cos x is the ka, so adjacent over hypotenuse. So looking at the triangle, adjacent is 5, hypotenuse is 29. That gives me 5 over root 29. Sin, is opposite over hypotenuse, so in this case that's 2 over root 29. So I've got my sin, I've got my cos, so I can use them in any of these expansions. So let's imagine we take the first one, so it's cos squared minus sin squared. So in this case that's 5 over root 29 squared. Take away the sin x squared, which is 2 over root 29 squared. Squaring both these, I get 25 over 29. Take away 4 over 29. Simplifying that gives me 21 over 29. If I was to use the second expansion, so 2 cos squared x minus 1, that would be the same as doing 2 times, well, the cos x was 5 over root 29, so that would be 5 over root 29 squared, take away 1. 5 over root 29 squared gives me 25 over 29, but I'm timesing it by 2, so that would then give me 50 over 29. And it's take away 1, but to work with it in this scenario, I have to write the 1 as 29 over 29. If I'm going to combine it and work it through, it has to be over a common denominator, which in this case, because it's just 1, is 29 over 29. Simplifying that gives me 21 over 29. Well, there you go. That's two of them the same. Let's just double check the third one. Let's just double check the sin squared. So in this case, the third one, 1 minus 2 times the sin squared, which is the 2 over root 29. So it's 2 over root 29 squared. Same logic as before. I'm going to write the 1 as 29 over 29, just so it'll be easy to work with. And then the 2 times 2 over root 29 squared, well, that bit there becomes 4 over root 29. Multiply it by 2, and I get 8 over 29. And in that case, that then becomes 21 over 29. When you're doing an expansion like this just shows it doesn't matter which of the three you use. As long as your values for sin and cos are right here, it doesn't matter. Pick one of them that you prefer to work with and stick to it. Second expansion was sin 2x. Now we know sin 2x is equal to 2 sin x times cos x. So it's 2 sin x cos x. Now we know the values for sin x and we know the value for cos x, so we simply substitute in. So in this case it's 2 times 2 over root 29 times 5 over root 29. Simplifying that, I do 2 times 2 times 5, so that's 20. And I do root 29 times root 29. That simply gives me 29. So sine 2x is given by 20 over 29. Now tan 2x, remember tan is equal to sine over cos. So in this case, tan 2x is equal to sine 2x divided by cos 2x. Now we've calculated sine 2x and cos 2x. We know sine 2x is this, 20 over 29, and we know cos 2x is equal to 21 over 29. So we can plug those values in. I know it's then going to be 20 over 29 divided by 21 over 29. Now remember, we've got fractions and we're dividing. Turn this to a times and flip the second one. So that becomes 20 over 29 times 29 over 21. Now looking across diagonally, the 29s will be able to cancel. What I'm able to then do is write it as 20 over 21. Job done, there's my tan 2x there. So we know these, we can simply substitute them in. The final one was sine squared x plus sine 2x minus cos 2x. It's all about now plugging in the values we know for them. We know what a value for sine x is, we know what the value for sine 2x is, we know what the value for cos 2x is. It's just a case of sticking it all together and seeing what we get left with. So sine x was 2 over root 29, but I know it's the 2 over root 29 squared. My sine 2x, well, we knew that that was equal to 20 over 29 from our previous calculation. And my cos 2x was 21 over 29. Square the bracket out and you get 4 over 29 plus 20 over 29, take away 21 over 29. They're all over a common denominator, so it's fairly straightforward to combine the whole shebang together. What you end up getting is 3 over 29 is your final answer. So this sort of expression, once we know these parts and we know our exact values, can all be fairly easily and straightforwardly done and combined together. Hope that went well. I'll see you in class.